Without further ado, let's start with our speakers. First, we have Shannon Baker. She's an award-winning designer who brings collaboratively approach that is focused on creative performance-based landscapes. She believes that good design resonates with people, and its incorporation in urban environments has the power to transform spaces into livable spaces. Shannon has worked across Canada and internationally at a range of scales, from large regional planning pieces through small-scale sites, and has been involved in projects from concept through to detailed design. Next up, we have Ken Dion, who looks exactly like he did in 2006. He received his Master's of Science from McGill University in Physical Geography, specializing in fluvial geomorphology in 1997. He has a background in watershed restoration and has managed large-scale city building projects for over 20 years. Currently, he serves as project director for Portland's integration at Waterfront Toronto. Some of his projects include the Don Mouth Naturalization and Portland's Flood Protection Project, which we're going to discuss today. Next up, we have Simon Karam. He has a Master of Civil Engineering and over 21 years of experience in the marine, structural, and civil construction industry. He holds a PMP certificate and a mini MBA Cycle 1 from the McGill Executive Institute. He joined Waterfront Toronto in 2007 and is currently leading the bridges and marine structures work on the Portlands. Last but not least, we have Joey Harrington, has a PMP with a Master's in Environmental Science. He served as adjunct lecturer at the University of Toronto and as project manager in the private sector. Joy oversees day-to-day earthwork activity and soil remediation on the Portland's flood protection, enabling infrastructure project, ensuring design and constructions meet project objectives. I'm going to turn it over to our first speaker now.
Yes, thank you very much. My name's Ken Dion. Thank you very much for the introductions. And I have to say, we are very excited to be invited to talk to you about the Portland's Flood Protection Project. This has been a long-going initiative, and we've been getting some really great progress, and we're thrilled to have this opportunity to show where we're at and where we're going over the next few more years. We've broken up the presentation into 4 different sections. I'll start off with an introduction, and then Shannon and Simon and Joey will get into specific components of it. And then I'll wrap up on how it sort of ties in together with a lot of the other work. Right now, for those of you who aren't aware of the project, it is, of course, located in Toronto. It is at the mouth of the Don watershed, which is one of 9 watersheds in the Toronto Regional Conservation Authority jurisdiction, and we're located in the Portlands area as the Don River enters into a shipping channel and called the Keating Channel before going into Lake Ontario. One of the drivers for the project has been for many decades identification that the area, because it is a lake-filled area, it's very flat and unconfined conditions, is highly vulnerable to flooding from the river itself. And hydraulic modeling has demonstrated that we're looking at about 290 hectares of land to the south and east of the Don River as being vulnerable under what's considered our regulatory storm event. In our particular area for Ontario, the Hurricane Hazel size event is what our regulatory storm is, which is much larger than the 100-year event, as you can see on the bottom right between the 2 different discharge amounts. The project area for the Portland's flood protection has been identified as the immediate area surrounding the mouth of the Don River and the Keating Channel. This is also the heart of a lot of other infrastructure activities that are currently underway. This is an area that has a lot of history over the last 200 years. This used to be the location for one of the larger coastal wetlands in the Lake Ontario drainage area. It used to be called Ashbridges Bay Wetlands. Back in the early 1900s, the Port Authority, which was the harbor commissioners at the time, decided that they were going to fill in the marshes and create a large industrial area to accommodate an expanding shipping industry and other industrial activities within the Portlands area. What you can see here is the creation of new dock walls that were created for the Keating Channel at the time, and you can see the remnants of the old coastal wetland used to be there. It also has quite a history of industrial activities once the Portlands were created. We had a heck of a lot of refining capacity that was located in the Toronto areas in the 50s and 60s and 70s before declines and the activity was discontinued and relocated elsewhere. As a result of that industrial activity, of course, we have a legacy of significant hydrocarbons that are located within the groundwaters and the soils of the Portlands area. We also had, during the wars, munitions and explosive manufacturing within the area. We had also, there's a significant amount of metal treatment, fabrication, and concrete and cement manufacturing is one of the main activities that are currently underway to this day. The Don River itself is a very sediment-laden river. It has always been known as high turbidity, high sediment loads. And that sort of contributed to the creation of the large wetlands in the first place before the city's development occurred. But of course, as soon as we put the river into a 90-degree corner with the Keating Channel and basically disconnected the mouth of the river from coastal processes in Lake Ontario, we ended up with a significant sediment management issue in the Keating Channel. We get about 30 to 40,000 cubic meters of sediment deposition in the Keating Channel each year, which needs to be dredged. Otherwise, it would rapidly fill in and substantially increase the amount of flood risk that occurs in the area. And of course, being one of the most urbanized watersheds in Canada, we also have a significant amount of garbage that floats down the river that has to be removed before it gets out into Lake Ontario. There's a lot of navigation on the inner harbor, and the Port Authority is responsible for trying to minimize impacts and collisions with those vessels by managing the debris before it gets into the lake. As you can imagine, habitat is significantly impacted in the area. You can see here looking westward of the Keating Channel. It is a deep channel. It's straight vertical concrete walls. There's a lack of physical habitat. We have a lack of vegetarian on the riparian or submergent areas. During the summer, we do get into, particularly hot summers, we get into some issues with water quality on low oxygen and high nutrients, which can stimulate the creation of significant algae blooms. And overall, the existing habitat is nearly non-existent for fish, birds, wildlife, and other communities. So that was sort of the existing conditions. This was a priority for communities since the 80s to try to improve. And over the 90s and early 2000s, we've worked together to be able to get ourselves in a position where the political powers to be saw the benefits of not only resolving the flood issue, but to greatly create and improve the ecological conditions of this river mouth in the area. 3 environmental assessments, 2 of them focused on the river and infrastructure around the river, worked in tandem, the Don Mouth Naturalization and Portland's Flood Protection Project and Lower Don Lands Master Plan, that basically identified a network of roads and infrastructure to go around the future river conditions were undertaken in parallel and approved in 2014 and 15. And then most recently, there's another EA that was completed in 2017, which is the Gardner East relocation and removals that will open up public access. Portions of that project, as you see, have been added to the Portlands project as of recently as December 2020. So we are taking on some of the works, particularly where the Gardner crosses the Don River before it gets into the Keating Channel. So the Don Mouth basically is looking to provide flood protection. It's to provide a naturalized river mouth and also to integrate and facilitate the establishment of a revitalized, sustainable community in the area. As you can see here, hydraulic modeling is centered to the overall project design process. If you recall the previous floodplain, when we have, with our preferred alternative for implementing a new three-pronged river valley system where we're maintaining the Keating Channel, creating a new naturalized base flow channel that goes south and then to the west, and then an overflow wetland that goes directly into an even larger shipping channel. The intent of this is to create a naturalized river mouth that goes through the central channel valley system to allow fish to go and other wildlife to move up into the watershed. But these two other spillways, one into the Keating Channel and one into the Ship Channel, provides capacity to split the very large regulatory flows into different ways to reduce the erosivity of that and basically provide multiple outlets for the floodwaters to get out and into the lake. The modeling has demonstrated for the Don Mouth EA that we can contain the regulatory flood event. We had a little bit on the EA north of the railway tracks on the east side, but we found ways to resolve that. And the main reason at the time we didn't do anything there is because most of that land is in private ownership and there wasn't development pressures to do that. And you can see how we also use the hydraulic modeling on the right-hand side, how we could even get into design parameters with regards to selection of different types of materials for stabilization of the vegetation and the valley walls based on the anticipated shear stresses that would occur. So we're using a very detailed night flood 2D model, very high resolution, and that allows us to really closely look at the influences of structures for existing piers and future piers and figure out the multiple pathways in which flows can occur through the different valley segments is core to the project. So our project, at the end of the completion of the EAs, we did a due diligence project that merged the Lower Don Lands Master Plan with the Don Mouth into a single project, which is actually about 23 very large projects all sort of tied together, grouped into different types of works. We have earth-moving valley construction projects, we have bridge projects and roads and infrastructure projects, and we have a series of parks that are associated with the overall program. And underlying all that is how do you manage contaminated soils left behind by the legacy of industrial activities. So with that, I will pass it on over to Joey, who will talk about how we actually constructed the valley system and dealt with the soil conditions in the area.
Perfect. Thanks, Ken. Thanks, everyone, for having us. Waterfront Toronto presented to your society in the beginning of 2019. Our colleagues Julius Gombos, Megan Janes, and Don Forbes went to a meeting, I think, in the Portlands at Cherry Street Barbecue. I don't know if it was the whole society or just the Toronto section, but at that time, site prep and demo was underway, but we really hadn't started construction in earnest. Since then, what I want to point out on this slide is that we've constructed, the river valley is about 1.5 kilometers long. It has cutoff walls on both sides in order to keep groundwater out. So we've constructed almost 3,000 meters of cutoff walls of various types. A number of secant piles in 2 phases of work, over 1 kilometer of slurry wall in the second phase, and we're currently constructing approximately 270 linear meters of diaphragm wall. This is a buttressed wall that'll form the west plug where the river will meet the lake. So I haven't included the length of those buttresses, but this wall will serve as a dam for approximately 2 years while we're constructing on the inside, on the dry side, and then eventually we'll cut that wall down and connect to Lake Ontario. We've also pumped and treated about 180 million liters of contaminated groundwater. Ken, can we go to the next slide? Here, there's a photo on the left is a long reach excavator with a specialized rock ripping bucket. This is what we used to construct the slurry wall. On the right is a crane with a hydro mill attached. Keller is the contractor. I'm not sure if you can see in that photo, but this apparatus is being used to construct the diaphragm wall. Next slide. We've also excavated greater than 300,000 cubic meters of soil. So the first step in our construction process was to build these cutoff walls, to isolate our construction area from the surrounding groundwater. We're connected to Lake Ontario with a very high water table and poor quality soils, so we wanted to ensure that we had a safe work environment, and we also wanted to make sure that we could limit the amount of groundwater that would require treating. So once the cutoff walls were installed, we started our dewatering process, and then we started to excavate soil. The total excavation is going to reach approximately 1.3 million cubic meters of soil, which is about the amount of soil it would take to fill the Sky Dome. Our reuse target is over 1 million cubic meters, so something like 80% is our goal to reuse, and that includes spoils from the walls, the secant pile spoils, the cutoff wall spoils. And the soil that we're excavating and reusing will be grouped into one of about 7 reuse categories. So these all have different environmental criteria and in some cases different geotechnical criteria. We know that approximately 300,000 cubic meters or more of the soil that we're excavating will require treatment prior to reuse. So what I'm going to focus on for the next few slides is how we're going to undertake that soil treatment, soil remediation. Thanks, Ken. So this is a really high level, I apologize that this is a bit blurry, but it's a really high level schematic of the soil management plan for PLFP. What I want to focus on here is what's circled in red, the remediation box. We just very briefly talked about how we would segregate soils. And the next slide, Ken. The way that we're doing that is really based on what's in this slide. The soil in the Portlands has a real variety of contaminants present. Most of them are related to the petroleum hydrocarbon kind of heavy industry that was in the Portlands historically, but there have been lots of other industries as well that are contributing to that contaminant mix. We have a number of different soil types ranging from like a highly organic soils, almost like peat, straight through to pure debris and garbage that needs to be disposed off site. Soil is often heavily saturated, so we have a range of soil moistures. We have a limited treatment area, very strict reuse specifications. There's only limited market capacity for us to get rid of soil, either for beneficial reuse or at a landfill. Of course, there are cost concerns, but our biggest challenge is time. Okay, let's go to the next slide. So based on all of that, what the project has ended up with is really 2 principal soil remediation options. The first one is bioremediation, and this was investigated in a treatability study in 2017 and pilot tests in 2020. The benefit of bioremediation is that it can treat large volumes of soil. It can handle varieties of soil types, and it also has the advantage of being able to handle a variety of contaminants, all in the soil matrix, all at the same time. Provided the contaminant load isn't too high, this is a good option. It doesn't take up too much space, and we have space available for this. And we've demonstrated through the treatability studies and the pilot tests that treatment should be possible in a kind of an 8 to 12 weeks or so. Let's go to the next slide. Sorry, Ken, just go back one. Oh, other way. There we go. Thanks. So what you're seeing in this photo is an aerial view of our soil management area. Those are windrows of soil that are undergoing bioremediation. In the bottom left-hand corner is our water treatment plant. But let's go to the next slide and we'll talk some more about bioremediation. So the way it works, for those that aren't familiar, contaminants provide the fuel and microbes that are naturally present in the soil will do the work. They need oxygen and nutrients in order to do this exercise. The microbes, this is not your standard probiotic, but they naturally occur in the soil. And what they do is they convert the long chain hydrocarbons into carbon dioxide and water, and usually heat energy. So this is a large scale science process. And we're managing all of these factors. We can control oxygen by mixing, we can control moisture by adding water, and we can control the nutrients. We're also measuring the effectiveness of the process by, of course, testing for contaminant concentrations, but also measuring temperature, measuring carbon dioxide from the pile, measuring oxygen in the pile, and so on. Next slide. So here on the left-hand side of the image is a standard diesel molecule. On the right is something called benzoate pyrene. Bioremediation doesn't work as well with the more complex molecules, so we knew that we would need to have a plan and a technology available for those more complicated hydrocarbons. But this is a quite effective method of dealing with hydrocarbons like diesel and gasoline that we have a lot of on our site. Our fallback is a treatment option called StarX. So Ken, let's go to the next slide. StarX is an ex situ smoldering combustion technology. This also underwent some on-site pilot tests in the spring of 2017, in 2018, and we did a larger scale pilot in the last winter, January of 2020. So the soils that we're targeting to put through this process will have higher contaminant concentrations. There's an ECA that the subcontractor maintains for this technology. It basically creates a clean, dry, because it's been heated, organic free, both free of organic contaminants and free of organic matter, mineral soil. So it's fairly quick. We believe that it's fairly sustainable and quite robust an option. I'll spend a few minutes explaining how does it work. So we use the PHC impacted soil as the fuel. We can inject air and add heat to get ignition. And once ignition has commenced, we can stop with the addition of heat, which is basically like a large electrical element. We'll continue to use the air injection to force the reaction through the treatment unit. And the combustion continues until all the fuel has been used. And at that point, puts itself out. So in the next slide, Ken, hopefully this works for you. There we go. Let's just watch. This is about a minute long. There's no audio, so you're not missing anything. I'll try to narrate. On our project, we're going to have 4 of these things called hot pads. And this is a Savron technology. So they load up these hot pads with contaminated soil. They cap it with usually soil from the previous batch or like a clean sand. Close the lid to keep the emissions under control. They all go to a carbon unit to be cleaned and then released. We're using electricity to create the heat, air injection. And once the fuel source catches, then we slowly smolder our way from the bottom of the unit to the top. That layer of clean sand on top snuffs the reaction. We're left with a whole box full of clean treated soil. So the units that we've built on site each hold 250 cubic meters. Each one is expected to take about a week to treat. So at any given time, we should be loading one, heating one up, cooling one down, and unloading the 4th one. So we're expecting about 1,000 cubic meters. Let's go to the next slide, Ken. We're expecting about 1,000 cubic meters of this soil per week to go through this treatment process. Here's quickly a photo of what the bench scale results look like. On the left is obviously the contaminated soil, and on the right is the clean, kind of organic free mineral soil. Looks a lot like sand. Next. I apologize for the angle of the photo on the left, but that's what soil looks like on site. A bit nasty. We loaded it into this pilot scale unit. I think there were 10 cubic meters in there. System worked effectively, and what comes out the other end looks like clean mineral sand or clean mineral soil. One more photo for me. This is what our setup looks like on site. So you can see I've got a couple of screen grabs there from the cartoon we just watched, but bottom left is a unit that's on our site. Bottom right is the aerial view. So we've got 4 treatment pads and 2 mechanical setup pads. There are 4 carbon cleaning units, and so this is how we're remediating the soil that we're going to treat prior to reuse. The rest of the soil will go directly from the excavation to be tested and go into one of the reuse categories and then get used appropriately. And that's all I've got. I'll hand it over to Simon to discuss bridges and marine works.
Thanks, Joey. Thanks, Ken. Good afternoon, everyone, and thank you for having us here. Today, I will be taking you through some of the key bridges and marine structure projects that we are delivering under the Portlands. I will first do a quick overview of those projects, and then I will dive in like a shallow dive into 2 of those that have already become an addition to the Portlands, i.e. they're already implemented. First, starting with the bridges, as a quick overview, the bridges are designed to reflect the distinctive qualities of the Portlands, as well as to become a landmark for the precinct. It will likely become a landmark for the waterfront and the city as well. You will notice through my presentation on the bridges that I included some design features. So here, for example, I included the feature lighting, LED programmable lighting that projects upward, lighting the hangars and providing effects. You could see on the image here, number 1 is the Cherry Street North Bridge that we're going to start with, which is the gateway to the Portlands. Then we're going to go over Cherry Street South Bridge, which is at the mouth of the river. And finally, we'll cover the Commissioner Street Bridge, which is number 3 here. And then I will be talking about Lakeshore Bridge modifications briefly. We can move on, Ken. So Cherry Street North, it's technically a twin. So it's 2 bridges here. One is for transit. The other is for vehicular traffic. This is the shortest of the family of those bridges. The exciting thing about this bridge is that, as you can see in the picture bottom right, it was the transit bridge was already delivered, and it was an important milestone for us back this November. One thing to note on the design of these bridges, all these new bridges, they share common elements. They all act as a shell structure under an arch loading. The design team led by Intuitive had endeavored to develop a very streamlined and elegant shape while keeping those bridges pretty transparent. And with that, they went with the steel as the element and the design that you see here. Another design feature here is the color. So the bridges have interior colors that vary from one to another. That will reflect also the unique character and in a 3-dimension and kind of illustrate the 3-dimensional shape in a closer experience. With that, we can move on to the next one. Cherry Street South Bridge is the second longest. It is 110 meters long. The previous one was a single span. This has a primary span and 2 secondary spans. As you can see here on Cherry Street South, the interior color is going to be yellow. And in the bottom left, you could see also an example of another design feature, which is the pier supporting Cherry Street South and Commissioner Street bridges, where the pier has a nice, elegant shape and also has a little bit function also in the way it reacts and behaves with water flows and ice flooding. We can move on, Ken. Finally, among the new bridges, Commissioner Street Bridge is the longest. It is 152 meters in length. You see it has 2 shell structures basically meeting halfway. This bridge will have the orange color in the inside and some exciting news or information about Commissioner Street Bridge. As you can see in the bottom left, it is well ahead in fabrication, and it is currently, this one will be delivered in 2 parts. The west part of it is what you're looking at, and it is currently in the paint shop, about to get painted, and we will be excited to receive it on the Portlands sometime this spring. So stay tuned. On the right side, just to illustrate the magnitude, this is one caisson for this bridge, and the same size of caisson we're using for Cherry Street South. So it's 2.4 meters. It goes deep, well deep to obviously through bedrock. We can move on, Ken. So with that, I'll talk briefly about the Lakeshore Bridge modifications. While the new bridges that we're discussing, the focus, not challenge, but like the effort, a great deal of effort had gone into the design. Lakeshore Bridge, we're talking more structures and engineering. So you see two bays here, that the existing bridge under the Gardner-Logan ramps. As you heard from Ken, the area there is subject to dredging and flows, river flows. We need to widen this bridge, make it twice as long. So you can imagine these two lengths on the west side, they will eventually be turned into water. So you can imagine what happens structurally here. You have live a ramp bands, so live bridge bands sitting right around that are today in soil, and they will become to water. At the same time, you could imagine equipment, deep foundation equipment, trying to go there and install caissons or some type of foundation with this limited reach, especially under the westbound ramp. So we've been in discussions, exploring opportunities with our colleagues at the city to analyze the possibility of accelerating the portion of the city's Gardner EA scope, which includes work on this ramp as well. Finally, the City Council had adopted the city staff report last December, supporting us entering into an agreement with the city to deliver these two portions of the projects together. So at the same time, the ramps, the overhead ramps could be removed and allow for the bridge to be lengthened and widened at the same time so that it could accommodate for all the modes of transportation implied for the spring. We can move on. This is some more information about the bridge. I don't think we need to get into details, but this is there for your viewing. We can move on, Ken. And that concludes the bridge overview. I'm going to move into the marine. So Portsmouth Slip Naturalization, it is just at the mouth of the river. So it's basically turning the Kozinski that you see there into a more naturalized area. It will provide shoreline support for this new area here, create a wetland within the river valley, as well as provide, can click next, as well as provide some recreational and ecological opportunities for this project. For this area. So here there's going to be a lot of dock wall work trying to stabilize the bottom portion of the wall and then taking it down, and then doing basically dealing with the soils, taking care of treating them, and kind of building up the layers to create the islands and then the finishings within that area. We can, one more interesting thing about the Portsmouth Slip is that it houses the Atlas crane, which we are preserving and which we believe, we understand it is the last of its kind in Lake Ontario. So sediment and debris management area is the next one. So again, going back to the fact we need to widen upstream of Lakeshore Bridge in order to allow the flow to slow down and encourage the sediment deposition there so that they wouldn't keep going down to the Keating Channel, as you saw the dredging used to happen there. Or even worse, get into the naturalized river. So that includes a lot of, so there's going to be deepening of the current channel, and widening is going to be, again, widened about twice as much. And there will be dock wall stabilization and new dock walls in order to support all this area. It's very integrated with the delivery of the Lakeshore Bridge, and it's pretty interesting, neat engineering and construction project when it comes to kind of tackling these two projects together, as well as the Gardner, as you can see. And you can click next. And you can see here also in the same principle, the bands are still existing. Eventually, they will be going part of the Gardner EA, the DVPRM bands here. So what we've done in the interim is we will be lowering this area enough to allow the flow water over top and the flood protect, but at the same time keeping it high enough to maintain those bands' structural integrity until they're at the time to go, and then this area could be taken back. We'll be building as much of the final structure as we could right off the bat, though, so it's easier to deal with there. Okay, move on. So finally, under the marine components, a flow curtain in the Keating Channel. When we started, that was going to be a combination of basically structured weirs. And as the design evolved, our team, led by MVBA, came to a more nimble system that would deliver the same requirements, but that's quasi more portable and efficient. So what it does, it just kind of this comprises of a boom, and the boom has a panel under, and then when the flows are slower, more water will be flowing in the river. As in the kind of more flood events or higher flow events, then the panels will rotate and with the direction of the flow, and more water will be making its way into the Keating Channel, relieving the river valley. Yeah, move on. Actually, this is the final one. Cherry Street Stormwater Lake Filling, 2017, we built it. This was the first that we had built on the Portlands. The CSLF, it stabilizes the shoreline around the Ezra Key and provides a lot of ecological habitat and opportunities, and also equally important, it supports the new Cherry Street North Bridge that you've seen already on site in the previous picture, as well as the realigned Cherry Street. Thank you, Ken. So now we're getting into the shallow dives that I described. The first one is the lake fill that we just went through. So you can see the design of the project. It comprises of about 200 meters of dock wall on the east side. And then you got the two coves, and this whole shoreline is about 400 meter long. And it was basically supported by a core stone core before we kind of went ahead and did some revetment. So I'm just going to show you some pictures of the construction of that project and how it evolved. Left picture is the very first barge that arrived to site delivering core stone material. It was as you could see, the lake was almost fully frozen. It was December 2017, and since then we received many more barges and deliveries. I put some numbers for the facts, those of you that like to see some metrics, and we can move on. There's some examples of the ecological habitat and the marine landscaping that were done there. You could see on the right, West Cove, and with you are only looking here, you're only seeing the trees that are like, these trees are not live trees. They are intentionally positioned in that way to contribute to the ecological habitat. There's a lot of trees and logs and sunken roots under that you won't see here. And in front of the other shoreline, for example, that you see in the bottom picture, the interesting part in the bottom picture, these are live trees, and they are stable within the naturalized shoreline, the armored shoreline. So we can move on to next. Now, a couple of shots from the same vintage point. This shows when we started the very first year in 2018. You could see the core stone. So in order to fill in the lake, obviously the material has to follow quality criteria, as well as we had to work within confined water bodies in order to comply with the confined lake filling guidelines. So we built, as you see, the green secans on that area. They are what we call interim berm. That was the quickest enclosure we could do to start filling, as we are building the other enclosures that are larger and took more time. So core stone as a core does the basic shaping, as you saw, came from the vessels. And here is a dock wall, and we can move on now, Ken. And as you see, as more enclosures we have more areas being filled. The bottom left part was filled first, as you saw, and then we were progressing behind exactly further beyond to do that line. finally we did the fill behind the dock wall. One thing worth noting here is that, two things actually, is that as closer to the camera, you could see the type of fill is different. There is a granular type material, and it is being intentionally used there in order to help us with the structural stability of the road and the infrastructure that will come over it and accelerate the time of the settlement required. And another interesting fact here is that we have received 24,600 trucks from local excavation sites, a material that would have otherwise gone most likely for. Move on. And this is an image of the kind of complete project. We had hydro seeding after that. The promontory part north that will eventually be built there is not funded yet, but right now we're looking into opportunities of potential interviews when the Portland is done. With that, you can, just because we're short on time, I removed like a time lapse, but you could see in the bottom a link to a YouTube video where it shows you a time lapse of the project construction, which is very interesting. Now we can move on to the last part of the project I'm going to be presenting. So this is going to be just like a little snapshot for you. The Portland's part 2 presentation will be actually just about this LRT bridge, as I understand. And I highly encourage those of you who are interested in the details of the fabrication and construction and design to attend that meeting. I think it is next Tuesday. So here you could see the bridge. This is all in a Cherubini Metalworks facility in Dartmouth, Nova Scotia. The bottom left is when the transit bridge was being fabricated. They start the fabrication with basically the bridge upside down. There's a cradle where they start doing the penetration welds and kind of put all these very thick sheets together that have already been pre-bent into the 3D shape in the Netherlands. And then basically once the shell is built, then they flip it upside down and start building the rest of the components. On the top right, you see the same bridge being in the painting shop. And finally, in the bottom right is a bridge basically ready to make its way to us. And that was another exciting journey for us when the bridge was sailing its way through the St. Lawrence Seaway and coming to Toronto. This is another link I forgot to put here, but you could look for Bridgewatch Toronto, Bridgewatch TO, and you could see a lot of footage about it, be it on Twitter or LinkedIn, and I'm sure other outlets. So just some images of the construction while the fabrication was happening in the shop in Nova Scotia. We were busy building the foundations here. So you could see, caissons work ongoing, as well as dock wall construction on the north side in order for us to rehabilitate the dock wall before we put the bridge on top of it and kind of limit the future opportunities of rehabilitating it. We can move on to the next. So more pictures about the construction progress and the formation and construction of the abutments. We'll move on. And again, in other shots, you could see more of the footage as this progresses, with also finally the bridge making its place. The last thing you'll be seeing a super quick time lapse of the bridge being rotated in place, and I'll be turning on the conversation. So the barge arrives in place. The bridge is rotated with cables using the dozers on the four corners. And once it's in place, the barge gets ballasted, filled with water to be lowered, and let the bridge sit on its abutment and bearing spots, and basically then just sails away. Thank you for your time, and I hope you enjoyed this. Now to you, Shannon.
Thanks, Simon. All right, good afternoon, everyone. I'm here to talk to you about the roads and municipal services aspects of the Portlands. And as you've gathered, I'm sure so far, we're digging a new river channel, and so that essentially creates an island. So as Simon has gone through, we've created a couple of new bridges to traverse those crossing points over the river, and the roads that we're constructing are associated with those crossings as well. So Cherry Street On the left-hand side is being rebuilt in a new alignment. So it's slightly to the west of the existing alignment of Cherry Street. Commissioner Street will be rebuilt in its existing alignment, essentially, and the Don Roadway over on the east side of the site is also going to be rebuilt. It's going to be rebuilt because it will have a flood protection landform underneath it, and so all of the services have to be removed, and the road needs to be rebuilt in its existing alignment. We're also installing all of the enabling infrastructure for the future Villiers Island, which is the new neighborhood that will come to this area once we've flood protected and the neighborhood can be built out. So the area that you see in gray, sort of interior to the river, Cherry Street and Commissioner Street, is going to be developed in the future. It's not part of the scope of work for the Portland's flood protection project. But we are constructing enabling services for that work. So water main, sanitary, a stormwater treatment facility, as well as a sanitary pump station for this neighborhood. So if you'd like to move on, Ken, we can go to the next slide. Waterfront Toronto has placed a high degree of importance on design excellence. It's a big part of what we do at Waterfront Toronto. And so the vision for each of these 3 streets is very strong. They each have unique identities. And particularly because Cherry Street is going to be the gateway into this new neighborhood. There's a number of different urban design elements that we've incorporated into the street in order to underline that character. Commissioner Street as well, because it's going to run along the length of the new river and River Park North, which is the massive park that we're building on the north shore of the river with nature play and dog off leash areas, picnic areas, and barbecues. Will be very similar to the character of the park, and hopefully visually will read as part of the park. And then the Don Roadway, also because it's adjacent to this new section of the Don River and an extension of that, we've incorporated that unique siting into the design approach for that street. So if you go to the next slide, Ken, you'll see a couple of renderings that give you an indication of where we hope eventually these streets will go. I mentioned Cherry Street is really the gateway into this new neighborhood, and it will be seen as very much an urban street. Eventually, when Villiers Island is developed out, it will have a very urban character to it. Commissioner Street, again, because it's adjacent to one of the new parks, we've really tried to pull the park across the street and take an approach so that you, as a user of the street, you really feel like you're immersed in the park itself and not part of an ordinary streetscape, let's say. And then again, the Don River, because it's adjacent to this new river and provides an opportunity for a promenade along the river. We've incorporated that into the design approach for that street as well. So as we move to the next slide, I'll take you through some of these design elements. So Cherry Street really takes its design reference from the industrial character of the Portlands. There are some salvaged elements that will go into the streetscape. So some striping that incorporates some metal pieces from what used to be the MT35 Marine Terminal 35 site, which burned down a couple of years ago, and some of the weigh scales were left in the parking lot. So those pieces will be salvaged and moved over to Cherry Street. And also a green infrastructure approach to all of these streets, and we'll talk about that a little bit more in detail at the end of the presentation. Again, really trying to lead with the landscape in all of these streets and set the stage for the development and the new neighborhoods that will be that will come along as the area develops out. We move to the next slide. So oftentimes, I think you probably have noticed that in renderings, the ultimate condition can be somewhat misleading because there's trees that are maybe actually 30 years old in the renderings, and things don't look exactly the way that they do on day one after installation of the project. So in this case, we did take careful attention looking at what the site will look like when it's finished. And again, it will be an interesting interim condition, because a lot of the development sites on either side of these streets will remain undeveloped until a few years in the future as those sites develop out as of right. So this was an important tool for us to be able to visualize what things will look like on day one after the Portlands is finished, because really the development of the neighborhood is a staged approach. Next slide. So Commissioner Street, again, a lot of effort to really pull the visual identity of the park across the street. The parks are being designed by Michael Van Valkenburg and Associates, and they are also the lead consultants on the entire project and have an integrator role. The streetscapes are designed by DTH and WSP, and so all three firms really work together closely in order to ensure that the design of all of the elements work together visually and aesthetically. Some considerations on Commissioner Street, because it is a fairly wide right-of-way, about 40 meters, and along Commissioner Street as well as on Cherry Street, we have made provision for a future TTC right-of-way, which had been contemplated as a BRT right-of-way at some stages of the project, and will in the future, in fact, be developed out as an LRT right-of-way. So we looked a lot at the ways that we could ensure that people could get across safely across the site, and we've introduced several mid-block crossings on Commissioner Street because it's a long cross section and crossing multiple modes, bike lanes, and a transit corridor, as well as just the vehicular lanes of traffic. And so we thought that was important. There's also no parking in the park because the whole approach for Villiers Island is really transit oriented, and there's an emphasis on walkability. So we thought it was important to make sure that these streets were porous as much as possible and that people could move across them safely. This is fine, Ken. Yeah, the design also takes into account some of the historical elements of the Portlands on Commissioner Street. So in many of the historical images, these columnar, they were poplar trees historically along Commissioner Street, were used to delineate and sort of create a rhythm along the length of the streetscape. In this case, we're using columnar oak, but with the same effect. And again, often in streetscape design, using these trees to create side friction on either side to sort of bring in the scale of the street, make it feel more pedestrian oriented, and slow cars down as much as possible to avoid conflict. Next slide. So this is another view of Commissioner Street looking west on the south side of the street. So again, a very different character, I think, than many of the streets in Toronto. Very much part of the park that is flanking it along its length, and we hope that focus reads as it's developed out. Next slide. So we're moving on now to the Don roadway, which, as I said, flanks the new river, and that its identity really takes a lot of inspiration from that location. The other interesting aspect of the Portlands, as you may know, is that it's very close to Tommy Thompson Park and the Leslie Spit, which is a major stopover for migrating birds on the North American flyway. And so we anticipate that our site, as the river is developed, will also become part of that overall ecological system. And so we decided to pay careful attention to the ecological characteristics of the streets and look at them as habitat as well as streetscapes that need to move cars and people and bikes and transit vehicles. So the scheme for the Don Roadway in particular focuses on more of a hedgerow approach, actually, which again is very unique in terms of a streetscape approach, but provides habitat for birds as they're stopping over, so resting places in the plant material, and also berries, so a source of food as they need to stock up for their long flight across. A conversation that we've had throughout the Portlands project is that while we certainly strive to bring nature into the city, and I think we all have seen throughout the last year how important it is to have access to nature in the city, that it also raises some challenges as well, because you don't want to create areas which might put wildlife into conflict with cars and trucks in the future. So a careful balance there in terms of the design to ensure that we're not, in fact, creating areas which might injure or cause harm to wildlife as they stop over as well. Next slide. And this is the view looking south along the promenade at the Don Roadway. This has changed slightly from this rendering, but as we develop out the details, as I said, for the flood protection landform, which is underneath the Don Roadway, some of these details have changed slightly, but the notion still is that there will be a promenade along the length of the river, and so that when you're part of the street, you can also be part of the river and move along its length. The Don Valley Trail also comes down the length of the Don Roadway and then connects down into the river. And so that forms a connection, a very wide regional connection in terms of cycling infrastructure, because you can connect into the entire length of the Don Valley Trail system, which loops around and will end now at Cherry Street, which is of course where the Martin Goodman Trail comes down to Cherry Beach and will be rebuilt as part of the cross section for Cherry Street as well. Next slide. So I mentioned the right-of-way of Commissioner Street is a wide one at 40 meters. In fact, all of these streets are wide. Cherry Street is also 40-meter right-of-way. And that was a bit of a challenge in terms of the design, because we wanted to create streets that were urban in character and very walkable, very cyclable. But we had, as you can see, a number of different modes of transportation to accommodate as we designed the streets. And we're also pretty proud that we've been able to retain a large section of these streets for green infrastructure and for planting. So Cherry Street is a quarter green, and Commissioner Street is 30% green. The Don Roadway is 42%. That's a little bit skewed, to be honest, because we've got a wide boulevard section on the east side that we can pull from. But again, just underlining the real emphasis that we've put on creating spaces that accommodate all modes safely and take a complete street approach, but also really underline the importance of nature, particularly in this area. Next slide. So lastly, just a little bit about the green infrastructure that we're implementing in the streets. Some challenges here, of course, because we're right at the lake, which means that we're basically, our groundwater level is up quite high, and particularly over the last couple of years with high lake levels, it really has been quite high and difficult to accommodate both in the stormwater system design as well as in the design of these features. So we've incorporated a number of different types of features, from open planters to bioswales and grass swales, as well as in some cases just a temporary landscape. This is in fact what the BRT corridor will be in the interim now before the LRT is developed, is a pollinator meadow with a lot of opportunity to capture water and keep it on the landscape and use it for trees. And to support the plantings within the plant beds as well. So 480 trees you can see there, a lot of trees that we're adding to this neighborhood, and just over 2 hectares of vegetated space. So again, quite a lot of green space that will be added to the streetscapes of the Portlands when we're finished. The next slide. Just a further detail on some of the mechanisms that we're incorporating, again, using soil cells in the open planter with passive irrigation. So in addition to providing enough soil volume to keep the trees healthy and improve their survivability rates, also providing space for infiltration as well. Some of the challenges that we've had here also relate to a bit of what Joey was saying in terms of the contamination, of course. So careful detail to environmental barriers and risk management measures for the streets to ensure that they remain clean and that these corridors are clean for the future. And a lot of geotechnical constraints as well. So we're in construction right now, just moving into some of the wet utility construction with microtunneling and HDD operations getting underway. And we've been surcharging a number of areas for, in some cases, a year or so. So as that material settles out and we get the compaction that we need, then we will be proceeding with the construction of Cherry Street and Commissioner Street, and lastly, the Don Roadway over in the east. So with that, thank you very much, and I'll pass it to Ken.
Thank you very much. This is the last section. Might not go through all the slides, so we can leave some room for any questions that may be, but I wanted to give a flavor of the complexity of the environment we're working in. I think our teammates earlier gave a really good flavor of the challenges we're facing to deal with the project by itself. And the logistics and the technical issues and the environmental issues are daunting, but we've been working closely for years to advance this, and it's been pretty impressive work to date. But we do also have to recognize that this also happens to be a center of a lot of other infrastructure projects, many of them really, really large, even larger in cost and scope than what we're proposing to do, that we have to work in a very, very coordinated measure to avoid contractor overlap. We're having agencies and developers working with us much more closely than you would typically deal with another public sector capital projects, just because, besides the fact that it's smart to do, but it's also required to do to make sure that we're not causing conflicts and that other projects will have to try to resolve. So this gives you an idea of what we have to deal with. For example, number one is the Metrolinx USRC staging area rail yards project that is underway to increase capacity in their storage of trains. 2 is our Portlands project. 3, we have a smart track station, East Harbor Station, being advanced on the east side of the Don River. We have the Gardner Works that we are now actually integrating into the PLFP project directly, components of that anyways, and there's other portions we have to phase in our work, as Simon had talked about in the sediment management area. We have the Broadview Eastern Flood Protection Project, and I'll get into a little more details of these. For example, with the Broadview Eastern Flood Protection Project, as I noted in the very beginning of the presentation when I was showing the hydrological map distribution after the Portlands was implemented, we were left with about 8 hectares of land that was left at risk of flooding. After all was said and done, on the north side of the railway embankment that goes into Union Station. The reason we didn't, as I mentioned before, address this at the time is most of the land is in private ownership. And we were originally able to come up with a concept where we proposed to raise the grade on Eastern Avenue underpass of the railway tracks so that basically water ponds on the north side. We've dropped the water levels from what was previous, but we don't resolve the issues and don't allow the water to spill into the South Riverdale precinct. After the EA was completed, city plans were looking at doing an extension of the Broadview Avenue for an LRT, which basically put another opening in the railway embankment. And then subsequently, other plans were coming along for a railway station, which you'll see on the embankment, which really gave us an impetus to look for a solution and do a final connection of flood protection works on the east side of the Don River. North of the tracks. So we were working with TRCA City and Waterfront Toronto to come up with the concept. Our EA is done. It's about to go out in the next couple of months for public and agency review, which basically proposed to put a flood protection landform as our preferred alternative that connects the Eastern Avenue underpass to the railway embankment in the south. And that will act as a physical barrier, permanent physical barrier to allow floodwaters to go underneath the railway tracks and into the Portlands area. However, we still have some private land ownership issues and there's long-term leases. And we came up with a phased approach to our ultimate preferred solution is where we create a landform in its final configuration on city-owned lands in the northern portion. And then we build the southern connection where there's railway expansion work occurring at the same time. And then what we'll basically able to do is raise the parking lot on the privately owned lands while allowing the commercial operations to work in the long-term period. And so this basically provides a permanent solution that eliminates that last little bit of flood protection in the area so that we ultimately have a long-term solution that addresses the full floodplain that was originally identified at the beginning of the presentation. And a flood protection landform is basically a very wide structure is intended to extend what's basically a naturalized valley that ends around Eastern Avenue, and we're basically extending that valley wall further south to the railway embankment in itself. So it basically is created such wide conditions that the risks of failure are essentially zero, whether it's due to the unlikely case where water overtops it, it can scour on the top and it won't be able to percolate through or seep underneath the structure. So that's an important piece because the Metrolinx is undertaking with Cadillac Fairview work on a new design for East Harbour Station. So this will be the first stop after Union Station. This will become a multi-transit hub for the future developments on the Cadillac Fairview site. And as you recall from the Broadview, we had issues with water coming underneath the underpass at Eastern and a future one for Broadview. There's changes that's coming with the station that basically makes this berm entirely porous, and we basically requires this new solution on the north side of the railway tracks to occur to allow this station work to come into play to maintain the flood protection. So we are working closely with Metrolinx and other partners to advance the approvals and hopefully all design and implementation of the total flood protection work. We also need to tie in with the flood protection on the south side with the Ontario line expansion, which is a new subway, which I'll get into shortly, which we need to work closely to make sure that our new flood protection structures in the Broadview Eastern work can be all integrated in the overall mass. So this is a new subway. This replaced the TT subway relief line that was in planning up till 2019. Metrolinx was assigned responsibility to take over. And basically this is a relief subway line that's being proposed to reduce the amount of traffic on the existing two main subway lines that feeds into downtown Toronto. This will be following along the elevated railway embankments and will be coming above grade within the USRC on the west side of the Don River train yard, coming up to grade and then crossing the Don River on two new arch bridges, and will require the widening of the railway embankment on the east side of the Don River where it ties in with the future East Harbor Station. And of course, any new bridge structures will have potential impacts on hydraulic conveyance with the incorporation of new piers. So all the work that's going in the design, there's a lot of coordination with the Metrolinx team to make sure that their bridge design it basically works in concert with the hydraulic flood protection solutions that we're developing comprehensively for the river in the area. And the main impetus originally for the Broadview Eastern Flood Protection Project I mentioned was the city's plans to put in an extension of the Broadview Avenue. So the city is currently advancing their own EA using the municipal Class A stage 3 and 4 to get into the details of what that road will look like as it goes underneath the railway embankment and back up into the future development block on the south side. That in the lands that are owned by Cadillac Fairview. This work also involves an improved connection from Eastern Avenue itself to the DVP. So we have some really significant integration requirements that we've been working with the city to make sure that our future flood protection landform on the north side of the railway embankment will be able to accommodate that enhanced road traffic that would be getting into the DVP. And in addition, the extension of the Broadview Avenue work also has to tie in with the new Lakeshore Boulevard East work that Simon and Shannon were talking about that has been recently added to the Portland's flood protection to make sure that that new road design coming in from the north fits perfectly with the work that we're advancing right now. And a component of the work that also requires flood protection, there's a large landform that Cadillac Fairview will be responsible for building on their own property along the Dawn Roadway, and the proposed east-west street that's identified in the Broadview Extension project needs to conform with the grading requirements for that future flood protection there as well. So there's a lot of integration work going there. This is reference to the Gardner Expressway. This is brought up many times throughout the presentation today. The first portions of the work, basically the overall EA involves the removal of the ramps to Logan Street, all the way to Cherry Street in the west. It'll be a wider, more public-friendly and a realigned Lakeshore Boulevard. And then there will be the removal of the existing ramps to the DVP and replacement of new ramps to the DVP from the Gardner, and this will open up a lot of development space. We've incorporated the Lakeshore Boulevard and the ramps up to the west side of the Dawn River. The city will come in afterwards when we're done the Portland's flood protection project and deal with the relocation on the west side of the Lakeshore and deal with the new ramp. So we Simon started getting into some of the challenges we had during the sediment management area and how we need to integrate those pieces of work for the sediment management area on the interim and final basis related to those DVP ramp works. I also alluded to the Union Station corridor. This is work by Metrolinx that is looking to expand their rail yard so that trains can sit during the off-peak hours during the day close to the Union Station. And this has significant implications in the scheduling and design process for our sediment management area. It also has implications with regards to the work that we're undertaking on the Cherry Street Lakeshore integration process so that we can get the new road alignment in. So there's some significant coordination that we've been working with on that. And the city has also been leading the Coxwell Bypass Tunnel project, which is a massive undertaking to intercept all the combined sewer overflows from Taylor Massey Creek down the lower Dawn River and across the Toronto inner waterfront so that those intercepted contaminated storm flows, so instead of going into the river and the waterfront, will end up in a large, deep buried pipe that are taken to a new landform and fast treatment facility that's going to be is under construction at Ashbridges Bay. But of course, this also has very large, deep, 30-meter diameter shafts going down to bedrock to intercept for access for the construction and maintenance of the tunnels. And these are, of course, interfaced within the Portlands area. So that work is well underway with their tunneling and the shaft construction. And we've been coordinating closely for years with the city team to make sure that their projects can interface with the Portlands work that's been underway, as well as the Gardner work. And I think this is my last slide. We alluded to it many times. The East Harbor precinct development is owned by Cadillac Fairview. They're involved in a partnership with Metrolinx, as mentioned, on the East Harbor Station. They're trying to create a massive new mixed-use development site with over 50,000 new jobs, with a lot of retail, cultural, public space, and entertainment connected by this new East Harbor multimodal station. It's also connected by the enhanced lakeshore that we're providing, and of course, close proximity to BVP. And it has a lot of integration work. We're working very closely with Cadillac to make sure we integrate not only the Lakeshore Boulevard work, their flood protection designs, as well as east. Broadview Eastern flood protection works on the north side, so that all of this can be delivered in basically in between now and 2026. So there's a whole slew of different sort of major engineering activities with a multitude of different agencies and interests that all have to work together to make sure that we can all achieve our various objectives all in a coordinated fashion. So that is it.